I'd like you to start with these very quick starter questions. Have a go at each of the questions from the 3 columns. In the first column, you're multiplying, the second column dividing, and in the third column, you're simplifying or breaking down the surds. Pause the video at this point so you can try each of the questions in the 3 columns. Give yourself enough time to do these, and then the answers will come up shortly. So, working through the answers very quickly. Root 3 multiplied by root 5, root 15. Root 2 multiplied by root 7, root 14. Root 2 multiplied by root 3, root 6. And root 2 multiplied by root 2. You should go straight to an answer of 2. You can go to root 4 and then 2. But really, if it's the same surd multiplied by itself, e.g. root x multiplied by root x, you should go straight to x. That's the simplest possible result. Now, the next one, 3 root 5 multiplied by 2 root 7. Remember, we looked at this last lesson. The 3 and the 2 multiplied together to give you 6. And then the root 5 and then the root 7, they just give you root 35. And root 35 cannot be broken down any further because 35 does not have any square factors other than 1, which we call the trivial square factor because we can't really use it to break anything down. Now, the last example, we'll do this in the same way. 2 multiplied by 4 gives us 8, and then root 2 multiplied by root 10 gives us root 20. So we have 8 root 20, but we can't stop there because root 20 can be broken down. So you'd never get full marks in a question like this if you didn't break down the root 20. So we've got 8, and instead of root 20, we're going to think of the biggest square factor that divides into 20, which is 4. So we've got root 4 multiplied by root 5, that's the root 20. And then breaking that down, that gives us 8 multiplied by 2 multiplied by root 5. So our answer to this one is 16 root 5. So make sure if you didn't get that right, or if you just stopped at 8 root 20, that you work that the whole way through. On to the divisions. Root 14 divided by root 2, root 7. Root 20 divided by root 10, root 2. Root 35 divided by root 7, root 5. And root 22 divided by root 2, root 11. And there's no further simplification on any of these. Now, with the column on the right-hand side, we'll just do 1 or 2 examples breaking these down using the technique you saw a few lessons ago. And then the other answers we will just fill in. So root 12, you want the biggest square factor, which is 4 for 12. So it's root 4 multiplied by root 3. The square root of 4 is just 2, so you end up with 2 root 3. Root 8 is 2 root 2. Root 18 is 3 root 2. Root 20 we just did previously, and that is 2 root 5. Root 27 is 3 root 3. Now root 48, we actually did this one in class. You don't want to break it down into root 4, root 12 because the biggest square factor for 48 is 16. So you want to start with root 16, root 3, and then it simplifies to 4 root 3. Root 32, in a similar way, you want to make sure you start with root 16 multiplied by root 2, not root 4 multiplied by root 8. And you get 4 root 2. Root 200, 10 root 2. So having done a quick warm-up, we are going to now introduce a new concept relating to surds, which is we're going to look at adding and subtracting surds. Can you make sure you have the heading written in your books, adding and subtracting surds? And today's date is the 11th of December. Now, we're going to start by actually thinking about algebra as a comparison. And when we're looking at algebra, there are certain structures that we can simplify and certain structures that we can't simplify. So have a look at the 4 expressions that I have written at the top of the page, and I want you to write them down in turn as we work through them. So the first one, we have 3x and 5x. We have like terms. We have 3 lots of x and 5 lots of x. I want you to think about what that would add together to make in your head. And if you're thinking 8 lots of x, you're absolutely right. Let's write that down. Now, in the second example, we also have like terms, x and x, and think about it, you're effectively doing one lot of x, add one lot of x, you simply get 2x. Note, the answer to that is not x squared, because you're not multiplying x by x, you're adding two x's together. So an x plus an x is just 2x. Now, in the next two examples, you don't have like terms. You have an x and you have a y here, for example. So this cannot be simplified. You don't have like terms. And the same in this example here as well, this last example, you have a 2x and you have a 3y. You cannot simplify unlike terms. So these are unlike terms. Now let's have a look at some similar questions, but this time involving surds. So I want you to write each of these examples down in turn and write down the notes that we make alongside. Let's start off with 3 root 2 plus 5 root 2. And hopefully you can see that the root 2 basically takes the place of x. So rather than 3x plus 5x, we've got 3 root 2 plus 5 root 2. Now, if we have 3 lots of root 2 plus 5 lots of root 2, that is the same as 8 lots of root 2. And you can see the similarity with the algebra above. Make sure you've written down that example. Now, in the second example, we have root 2 plus root 2. So again, the root 2 takes the place of the x in the algebraic example. Think about when we had an x add an x. We had 2 lots of x. A root 2 plus a root 2, we simply have 2 lots of root 2. So your surds behave in a very similar way to your algebraic terms. Make sure you've written that down. And in the third example, x plus y, they were different terms, they were unlike terms. So I'm going to write down an example involving unlike surds, root 2 plus root 7. Now, it's very tempting to think that that might be root 9, which is 3, or some other example which is incorrect, but actually, root 2 plus root 7, these are unlike surds. So you cannot simplify a statement like root 2 plus root 7. Make sure you've written that down, because those are different surds. And the same with the last example. If we have 2 root 2, so root 2 takes the place of x, plus 3 root 7, where root 7 is taking the place of y here, again, these are unlike surds. They cannot be simplified. So you cannot add these surds together because they're not the same type of surd. You'd need to add together root 2s separately, or root 7s, but you cannot add together a root 2 and a root 7. Make sure you've noted all of this down. So let's have a look at an example here. Imagine we have root 2 plus root 5. I want you to add that together on your calculator and see what the calculator gives you. It probably gives you root 2 plus root 5 on your screen, and it clearly doesn't simplify it any further. If you use the SD button to simplify it, see what you get. Now, if you do this on your calculator, you will see that you get an answer of 3.6502 ... which is the non-recurring decimal representation of this surd. So, as you can see, it is not the same as root 7. You can check root 7 separately, and that's equal to 2.645 ... So you can see very, very clearly that root 2 plus root 5 is not the same. That sign means not equal to root 7. They are two different surds. And you cannot add together root 2 and root 5. These are unlike surds. You cannot simplify them. Write down the following, please. We can only collect like surds. and we're going to work through a series of examples where we've got like surds. Let's have a look at these carefully. We've got 6 root 3 plus 7 root 3, like surds. 6 lots of root 3 plus 7 lots of root 3, have an answer in your head, it's 13 root 3. We're going to do the same with each of these examples. 10 root 2 minus 6 root 2. Well, that's a little bit like doing 10x minus 6x. If you're not sure in any of these examples, just do an algebraic example to help you. So for the first one, 6x plus 7x would be 13x. 10x minus 6x is 4x, so 10 root 2 minus 6 root 2 is simply 4 root 2. The next one, 5 root 5 plus 11 root 5, you've got 5x plus 11x, so the x replaces the root 5, that would be 16x. So here we have 16 root 5. Next example, 7x minus 6x. Now, x again is taking the place, root 6 is taking the place of my x here when we do the surds example. Now 7x take away 6x, think about this carefully. You've got 7 lots of something, take away 6 lots of something, you've got 1 lot of it. You've got an answer of x. So 7 root 6 take away 6 root 6 is 1 lot of root 6, but we would never write 1 times root 6. We can just write root 6. Now, be careful with the next example where we've got 4 root 3 take away a root 3. The answer is not 4. Think about when you have 4x take away an x, which is the same question expressed algebraically, the answer is not 4. You're not just disappearing the x. You're doing 4 lots of something, take away 1 lot of something, which gives you 3 lots of it, 3 lots of x. So the answer here is 3 root 3. Right. The next question, 8 root 2 plus 4 root 6. Well, in this question, you have a pair of unlike surds, so you cannot simplify this any further. And in the next question, you've got 2 root 6 plus 3 root 3 minus root 2. You cannot simplify. It's really tempting, and I always see people try and do this because they see the root 6, they see the root 3, they see the root 2, they try and break down the root 6 into a root 3, root 2, but that doesn't help you. You'd need an integer number of root 3s or root 2s to be able to simplify this. You cannot simplify it any further. You've got unlike surds. That last example, 2 root 6 plus 3 root 3 minus root 2, well, that would be like 2xy plus 3x minus y, and you can't simplify that because xy is a different term to x and to y. So there's nothing you can collect there. Now the last example, root 17 plus root 17, you simply have 2 lots of root 17. Now, have a look at this next example. I want you to write it down. Root 20 plus root 45. Now, at first glance, those appear to be unlike or different surds. And it might feel like you can't then simplify this any further. However, both of these can be broken down, and that's what we're going to need to do first of all. So, let's look at root 20 and then we'll look at root 45. So, starting with root 20, well, we know that root 20 is root 4 multiplied by root 5. Remember, we look for the biggest square factor, which is 4 of 20, and then that simplifies to 2 root 5. So root 20 is the same as 2 root 5. Let's now look at root 45. The biggest square factor of 45 is 9. So that's root 9 multiplied by root 5, so that's 3 root 5. So root 45 is the same as 3 root 5. So instead of root 20 plus root 45, we can write down 2 root 5 plus 3 root 5. Now, we now have like surds, so 2 root 5 plus 3 root 5 is the same as 5 root 5. So you have to be very, very careful when you get bigger surds, so not just root 2s and root 3s and root 7s, surds which have square factors, you have to break down first of all and then add together. Let's write that down. Now, having just done this first example, we're now going to look at the following 3 examples together. We're going to work through each of them, making notes as we go along. Let's start with 2 root 18 plus 6 root 8. So we've got root 18 and we've got root 8 to deal with, but we've got 2 lots of them as well, so there's quite a lot going on in this question. So you can see we've got 2 lots of something and 6 lots of something. So let's start with root 18. So root 18 is root 9 multiplied by root 2, so 3 root 2. And then root 8, let's look at that. So that's root 4 multiplied by root 2, which is 2 root 2. So just so I can colour match this for you, root 18 is the same as 3 root 2, root 8 is the same as 2 root 2. So here in this question, we've got 2 lots of, and instead of root 18, I'm going to write 3 root 2. And I've got 6 lots of, so over here, and instead of root 8, I'm going to write down 2 root 2. So hopefully with the colour matching, you can see which bits match up. Root 18 is the same as 3 root 2, root 8 is the same as 2 root 2. Now last lesson we learnt how to multiply surds and whole numbers together, integers together. So 2 times 3 root 2 is 6 root 2. 6 times 2 root 2 is 12 root 2. Remember, that's a bit like doing 6 times 2x, which is 12x. X is like your root 2. And now we can do the final stage that we've looked at today, which is to add the like terms together. 6 root 2 plus 12 root 2 is 18 root 2. Now you can see, just in a simple looking question, there is quite a lot of work that you've got to get through. Let's have a look at this next example. Now we've got 5 root 27, take away, so subtraction 2 root 12. Let's start with root 27. Now breaking it down, root 9 multiplied by root 3, it's 3 root 3. Root 12, root 4 multiplied by root 3, it's 2 root 3. You may already be able to see where this is going. So I've got 5 lots of, and instead of root 27, I've got 3 root 3. And then take away 2 lots of, and instead of root 12 we can write 2 root 3. So again, have a look at the colour matching to help you. 2 root 3 is the same as root 12, and root 27 is the same as 3 root 3. I'll highlight this in red there. So I've got 5 times 3 root 3, which is 15 root 3. Take away 2 times 2 root 3, which is 4 root 3. If I have 15 root 3, take away 4 root 3, I have 11 root 3. So the next example, 6 root 24 plus root 48. Let's work through this again. So we've got a 6, a root 24 and a root 48. Let's start with root 24. So bigger square factor is is 4 of 24, root 4 multiplied by root 6, so 2 root 6. So I can now do this part here. So root 24 is the same as 2 root 6. root 48. Now remember, we've talked about this one a lot. The biggest square factor of 48 is 16. So we want root 16 multiplied by root 3. So 4 root 3 is our most simplified version of root 48. So this then gives me 6 lots of 2 root 6. So there's my root 24. Plus, and instead of root 48, 4 root 3. And then a little bit of further simplification, 6 lots of 2 root 6. This part simplifies to 12 root 6. And then this part, I just have 4 root 3. Now, these are unlike surds in this final answer here. We can't simplify the root 6 and the root 3 further. They're not going to simplify to root 9. They're not going to simplify to root 18. They're not going to simplify. Root 6 is like an x and root 3 is like a y. So it's like having 12x plus 4y. And you know you can't simplify this any further because these are unlike terms. So the final answer to this question is 12 root 6 plus 4 root 3, and a key part of this process is understanding when you can collect terms and when you can't simplify any further. So I now have a series of questions for you to try. Even though we've done something quite similar or the same as the first question, part A, before, I want you to make sure you've done that. I want you to work through all of question 11, parts A through to H, and then I want you to start question 12 and then work through as many parts of question 12 as you possibly can. Now, the answers are below. You should use these to check your working for each of these questions. Do the question, check your answer, and then move on to the next part of the question. So don't try and do all the questions and then check your answers. If you go wrong, you're going to be very annoyed with yourself if you then have to go back and correct all the questions instead of perhaps just correcting one question and then learning how to do the second question correctly. If you need any help, go back through the video and check how to complete certain steps. Make sure you show full working, and you should not be using a calculator for any of this work at all.